Science is real, from the Big Bang to DNA. Science is real.
In Reel 3, you will begin your data analysis by compiling your results. These include your flame atomic absorption results, the ion chromatography results, the XRF results, and the soil organic matter results. With this information, you can move on to the discussion. For the AA results, you will need to make calibration curves for both metals tested. Make sure that your calibration curve is properly fit in the area where the values for your unknown samples lie. Your concentration values will be entered into a data report sheet. Your results will probably look something like this. Notice how the initial concentration includes several fractions. Recall that when the samples were initially added, two different solutions were used. This means a given solution's concentration was cut in half. Make sure you are reporting the data properly in this manner. Experimentally, you determine the concentration of cations remaining in solution. If they are no longer in the solution, it is because they are adhering to the soil particles. Let's turn next to the ion chromatography data. Recall in Reel 1 you added a known amount of soil and a known amount of water to a bottle. The bottle was shaken for about 10 minutes and the resulting solution added to an IC vial for analysis. An IC instrument is shown here. The output from the instrument, called a chromatogram, is also shown. Notice how different peaks are shown for the different components in the sample. The size of a particular peak, or its area, increases as the amount of sample increases. This means you can calibrate the instrument by first testing samples with known concentrations and measuring their area values. In this example, as the amount of sodium increases, so too would the area of the peaks corresponding to sodium. To construct a curve like this, you need to know the amount of sodium in the sample and also the area values from the instrument. Information about the different standard solutions is given in Reel 3. With this information, you can calculate the concentration in ppm for each cation and enter it into the table provided. A few entries have also been provided to make sure you are doing the calculation correctly. A sample calculation is also shown for conversion to parts per million. You will still need, however, the area values. These are experimentally determined and will be given in your lab. With this information, you are now prepared to make calibration curves for each of the cations listed. A Google document has been prepared that includes the class's IC data. A link to the document is found within Carmen. Here, for each vial, you will find area values in terms of sodium, ammonium, potassium, and the other cations. With your calibration data, you can turn these area values into concentration. Record these concentration values, both in your notebook and the accompanying datasheet. On the datasheet, you will also report your XRF results and the soil organic matter results. You are asked to report these values in another Google document file. The first step in data analysis is to compile your results. With this information, you are now ready to move on to the discussion.